Hello everyone, my name is Timothy Lee Grant. Today I am going to be going over greedy algorithm and trying to see if I can do some of the Leetcode problems. So I am by far not a professional, so this is going to be just me working through some problems, seeing if I can solve them, and then trying to find what we can learn along the way. So let me come here and make myself a little bit smaller. And let's kind of randomize it. So where are we stopping? This one, it's already done. Okay, let's go here, this one. All right, so we know that it is greedy, so we're gonna be looking to find out how can we take the optimal option at each point that we need to make a decision. Okay, so I'm given a string S, all right? We want to partition the string into as many parts as possible, okay? So that each letter appears in at most one part. At most one part, okay? For example, the string A, B, A, B, C, C can be partitioned into A, B, and C, C. But partitions such as ABA, BCC, or AB, CC are invalid. Okay, I don't understand why. I'm gonna have to reread that maybe. Okay. So you are given a string S. We want to partition the string into as many parts as possible so that each letter, okay, so here's the condition that makes it invalid, such that each letter appears in at most one part. Okay, so the reason that these two are invalid is because a B is right there and a B is right there. But notice here, A and B, so A only appears in this section, B only appears in this section, and then this one, C only appears in this section, okay? And I think what's happening is also I'm not allowed, obviously, to switch up the lettering order, because then the solution would be just put each letter in its own category, and then there you go. Okay, all right, so I'm seeing kind of what we have to do. I don't see immediately how to do it. My first instinct would be, okay, well, I have this, and I am forced. So if I have an A here and there's an A right there, I'm kind of forced to include it, and I would only have one. Okay. So then I guess my question would be, let's say that there's like this. I have this A, and I know that I need to include this A. Okay, so I have to come here. The next question is, do I break it right there? Well, no, I can't break it right there because I need this B here, and I need the B here. Okay, and I need the B there. All right, so can I break it here? Well, no, because now I need this C, which is found right there. Okay, so then I need to include all of this. And I notice that there is also an A right here as well. So I need to go like this. Okay, and now I think, unless I'm not seeing any, that this one right here would be a valid string. okay? And then I can break it, okay? And I want to break as soon as possible. So now I'm going to include this D. Are there any other D's here? Yes, there is right there. So I need to include all of this, but can I break it here? No, I can't, because there's an E here, and I need to include that E. So I at least need to do this, okay? Can I break it now? There's no other F's, there's no other E's, there's no other G's, and there's no other D's, so I can break it, bam. So then I'm gonna do this H, okay? Can I break it here? No, I can't break it because there's another H right there, okay? So I need at least this, but can I break it here? No, because there's an I there and an I there. So I need to go at least to here. Then what I need to do is look, oh, but I see a J right there. So I have to go there. Okay. Now how to actually do that. So, right now I'm thinking in my head, what are some of the different data structures that might allow me to search for the letters. So what I'm thinking about doing is having some kind of dictionary, okay, where the key is the letter. So the key is going to be, like for this one, A is going to be the key, and the value is going to be the frequency, how many times it appears in this entire string. So A is going to have a value of 3. Then what I'm going to do is I'm going to come here and I'm going to keep going until I find A 3 times, because I know that I need to include that, okay? So I'm going to do that, and then I'm going to have another dictionary that keeps track of all of the letters in my current substring, okay? And so as I expand out, I need to try to think, what kind of data structure can I use to keep track of if all of the letters are taken care of? So as I'm expanding, I need to, could I put in a set, which is, and then once I'm thinking I put it into like a set. And then each time I come into another letter, so let's say that I take this A, and I know that I need to have this A. What I'm going to do is I am first going to decrease the value. I'm going to put my A in my set for current word item, or current word letters, right? And that means I need to grab all instances of A. Okay. And it's in my set, so I need to take that out only when I have already gotten all instances of A. Okay. But now what I do is I decrease the number of times A appears, like its frequency, right? Because I just grabbed it. So I need to decrease it in my dictionary. And then I check, like, okay, well, if my dictionary for A is all gone then I can break the word right there. So let's pretend that this A and that A didn't exist. Okay, so I come here, I'm going to add A to my set, then I'm going to decrease the frequency, which is 1, because there's only one A in this string, and then it's going to go from 1 to 0, okay? Then I'm going to say, aha. What I'm going to do is I'm going to now take that A out of my set, and then check if my set is empty, and if my set is empty, I can break it, okay? All right, so let's kind of do that. My dict equals default dict of an int, and we are going to have key value, where key is what? Key is going to be the letter, and value is going to be frequency. Okay, so now I'm going to loop through the entire array. So for element or letter in string, I am going to do my dict indexed at letter plus equals 1. So I'm just adding 1 to the frequency. Okay, so now what I want to do is I want to go and so I'm going to have a pointer that actually I don't need a pointer in Python. I can just do for letter in S again. Okay, so now what do I want to do? I want to have a set. So, okay, word set is equal to set, like this, and then I want to add that letter to my set. So word set dot add letter, okay, and then I want to check, or I want to decrease the value, right, in my dictionary, because I just added that. I'm also thinking that the output is like how many letters we have, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I need some way to keep track of that. So current length is going to be equal to 0. I come in here and because I just added this letter, I'm going to do current length is plus equals 1, okay? And then answer array, answer is going to be equal to an empty list. And then I'm just going to append that each time I break the word, okay? So now, what do I want to do? Okay, so I just added the word, but now I need to decrease the frequency, right? So I have my dict of letter, okay, minus equals 1. Now, if my dict of letter, is equal to 0, so if that letter is all used up in the entire word, right? So for this one, we're going to have A has 1, 2, 3, 4, so frequency of 4. I'm going to come here, and once it gets to this position, A is all done, and let's pretend all of these don't exist. It's just the other A's, and so then I can break the word right there. So what I want to do is I can take this out of my set, right? So word set dot remove letter, okay? And now if I have any letters in my set, I can't break the word. As I was saying, like with this one, can I break the word right here? Well, no, I can't, because there's a let's pretend that there was an E in here, right? Like, then I wouldn't be able to break it. So I need to make sure that I've already gotten all of my letters accounted for. So if word set, I should say if not word set, then I want to break the word. Okay? So now what will happen is I need to add the current length to my answer. So answer dot append current length, okay? Then I need to set current length equal to 0, so reset it. And then I don't need to do anything with my dictionary, because that's just going to keep going as I'm not putting these letters back in, right? So I'm just going to keep it the way that it is. Do I need to do anything with set? No, because set is already empty. So as I go up to the next letter, I'm going to add that next letter in. Okay. And then once I break out of this, I can return answer. All right, so let me kind of go through this example number 1 and try to see if it is logical, okay? So I'm going to take this and make a comment. Okay, so we're going to start right here, okay? So now I'm going to add A to answer. So I can go like this. Okay. Okay. So answer is like this. Current, gonna go is a set, like that. Okay. So now what I'm gonna do is I am going to come in here and I'm at this A right here. Okay. So now I'm going to add A to my set. Add A. There we go. I'm going to increase current length by 1. Okay. Current length by 1. I am going to decrease the frequency of all of that. Oh, okay. So that's going to be a pain to actually write out. Okay, how would I do this in a real scenario where I need to walk through my code? I'm not sure how I would do that. But A is going to have so now I'm going to have like A4, kind of like this. So now I'm going to decrease 4 to 3. Okay? Now I come here is my dictionary equal to 0 of A? No, it's 3. Okay, so I don't do that. Is my word set null? So if not, word set. No, it has a value of A. So I don't do this. Then I come back up here. And now I add the next one. So now I'm no longer here, I am here. So I'm looking at the B. So now I add B right there, okay? And current length is now equal to 2. And I'm going to have another entry here, which is B. And I'm not adding this. All of this actually gets built up here. Like, that's where it gets built, but I'm just getting the default values. So B has a value of 1, 2, 3, and it looks like that's it. So 3. Okay. So I come here, I add B, I increase the length to 2, I decrease this value to 2 right there. I check if the letter B that I just decreased was the last letter in the dictionary. So I've gotten all of the other B's in the string, which it's not because B has a value of 2. Okay. Then I come here to word set, so I see if my word set is empty. It's not. So then I just come back up here. So now the next one is going to be A again. Okay, so I already have A in my set, so I don't do anything. Current length is going to be 3. A is then going to be decreased to 2. This does not hit because A of 2 is not there. This does not hit because I have AB, okay? Then I go to the next one, which is this one right here, so B. I try to add it to my set, but it doesn't add because sets are unique and unordered and, yeah, unique. So I can't have 2 B's in my set. So then I come here to current length. So current length is 4. I decrease B by 1, like that. And then this doesn't hit and that doesn't hit. Okay, so then I come back up and then I see a C. Awesome. So now I go here to C. I go, current length is 5. I now check to see what my C was from up there. So C is going to be 1, 2, okay, 2, okay. So then what I do is I decrease this value to 1. This doesn't hit and that doesn't hit. Okay. Then I go back up. And I go to B again right there. B. So now B is, I add B to my set, but it's already in my set. I increase current length by 1, so that is 6 now. I decrease B to 0, okay? Now notice, there's no other B's in there, okay? So this one, now, my dictionary of B, is it equal to 0? Yes, it is. So we come in here and we remove that letter from my set, like that, okay? Now I say, is my set empty? Well, no, it has 2 values still, so then I come back up here. All right, so then I now go here and I'm looking at this A, okay? So I try to add A, but it's already in my set. Current length is increased by 1. I decrease A's frequency by 1, okay? And then I come here and ask, is A's frequency equal to 0? No, it's not. And this also doesn't hit because our word set is not empty, okay? Then I come back up and I'm here and I'm looking at this C. So I try to add C, it's already in there. I increase the current length by 1. And then I decrease the frequency of that C, so it's equal to 0. I then look to see if my frequency of C is done. So if I've gotten all of the C values in that string, which yes, I have, so I can remove that from my set. Okay. Then what I do is I check if my set is empty. It's not. So then I go back up here to the next one, right there. So now I say, okay, well, I'm looking at A. I try to add A. It doesn't fit because it's a set and it's already in there. Current length, I move it up to 9. I then look here, and what do I see? I see this right there, so I decrease it. Then I say, is A frequency equal to 0? Well, yes, it is. That's the letter that I'm currently working on. Awesome. So now I remove it from my set. Then I say, is my set empty? Yes, it is. So I add current length, which is 9. I add 9 right there. And then I set current length equal to 0. Okay, so that indicates that I just broke the word right there. And if we look at the answer, 9 is in fact there. So then I'm going to go through a couple more, but that kind of gives the overall understanding of how this is operating. So then I can move on to this D. Okay, so now I'm on D. And here's the states of all of my variables right now. Kind of like going through the debugger, right? Okay, so now I add D to my set. There we go. Then I do current length plus 1. Okay. Then I decrease the value of D, and D was found up there. So D is here and there. So I have a D and a value of 2. So D2. Okay, so then I decrease it to 1, which means that there's only one other D in this string, which is true. Okay, so now I say, is my letter equal to 0? No, it's not, so that doesn't hit. Is my word set empty? No, it's not, so that doesn't hit. Then I come back up here and I move to the next letter, which is an E. I add E to my set. Okay, then I increase current length. Then I check how many values are in E, and 1, 2, 3, so 3. So I decrease that by 1, and then this doesn't hit and that doesn't hit. Okay, and then at the end of this, I will have appended all of the answers here. So I think this works. I'm going to tentatively run it. I don't know. I hope it does. Okay, it passed its test cases. Come on. Yes! 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 Okay, okay, cool, 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 cool. Awesome. Ha. Okay, there we go. We got it. We got it. Wow, that's fun. That's fun. Oh, that's really cool. Okay, I'm. All right. Well, thank you guys for watching this video. If you liked it, subscribe. I'm gonna be making more leak coding videos. Obviously, I'm not a professional at this. I am trying to learn as much as I can, try to figure out what's happening and improve myself, right? So this is kind of like an amateur goes through these problems, and hopefully that is also of value to you, possibly, if you're trying to struggle through it, and maybe getting a different perspective from someone who's not a professional might be helpful. If it is, subscribe, and I would love to have you along in this journey. So I'm going to keep making more of these Leetcode videos. I also do some project-based videos, specifically trying to target back-end software engineering. So that's kind of the path that I'm trying to get into. So yeah, subscribe if that's interesting. The other thing that I am realizing is I should try to kind of reflect on this problem. Like, okay, well, it's greedy, and what does that mean, right? Like, so I have this string, and I am taking a greedy approach, meaning at each time that I find a solution that fits the certain criteria. In this case, that all letters were taken account of, then I could break the word. So that's what I was looking for, is greedy, right? So in this problem, I was looking for the smallest word which fit a criteria, which the criteria was given in the problem to be that one word needs to contain all of the letters present within the overall word. And then once that condition was met, I could immediately take that word as the word that I wanted. So that is the greedy part of it. And then I used data structures such as a set and a hash table to be able to implement that method or that algorithm, the greedy algorithm, okay? And so my sets and my dictionaries were they allowed me to actually do the process. So the dictionary allowed me to find the frequency, which I needed that information. So it gave me information. Okay, so the algorithm is how I was performing this, but then I used the data structures to give me information and look up information that I needed. Okay, so I'm trying to just make sure that I reflect on every problem that I do as well, not just solve it and then just leave it. So yeah, thank you for watching this video, and I will be back with more videos shortly. So hope everyone is having a great day. My name is Timothy Lee Grant, and I'll see you guys very soon.